to the other one. So I have this one. Don't start like running. This is Argo CD with a bunch of apps. So let me share some of the architecture diagrams that we were working on. Do you see these diagrams? Do you see them or not showing?
They show. I haven't seen them before.
Oh, okay. No, I was asking if you see that you see them here in my screen.
I see them clearly. Yes.
Okay. So this is a pattern that we are trying to teach folks of like running multiple Argo CDs or multiple EKS Kubernetes clusters. And the idea is that we want to show people how to, this is an architecture of like a typical like VPC where you have multiple availability zones. And then in that zone, we install an EKS cluster. We call it the hub cluster. Let me see if I can zoom in on this one to show better. And typically what people do with this pattern, Argo CD supports this concept of like remote clusters. That from one Argo CD, you can deploy apps to another Kubernetes cluster that doesn't have Argo CD in it. So it's kind of like an external push of like configurations. That works for certain environments, like if you are in a close network proximity. And also like that Argo CD to those other clusters will start like fetching the information to like know what is the desired state and what is the current state. And one of the problems with that pattern of having one Argo CD managing a lot of Kubernetes clusters is that transfer of network information. And in some environments, you get charged for that. So that's one problem. Another one is like the networking, private networking is not allowed. Like you cannot talk to another cluster that's located in another place. And then the last one that we want to show is, and we have shown some patterns of like Argo CD cannot scale horizontally to manage so many apps. Like if it's going to manage, if every Kubernetes cluster, let's say I have 1,000 apps and you have 100 clusters, like it's too many apps. And the Argo CD UI doesn't scale to more than maybe 2,000, 3,000 apps, the UI, the web browser. So another pattern is to have a distributed model where you have the clusters and maybe have a better idea, a different pattern on that. This is the patterns to have distributed model of those Argo CDs everywhere, and they all work from the same repo. Is this showing up for you folks, the diagrams?
Yes.
So that's one pattern of like having every Argo CD distributed everywhere. That's a pattern. This is the one that was showing like this scales to a certain degree, but it gets to a point that this Argo CD is using a lot of CPU and memory, for example. That and also it's kind of like a single point of failure. If this Argo CD gets is down or something like that, and you have to update something in one of the Fleet clusters, then you have that isolation. But with every architecture, there's trade-off, right? It can work in certain situations and others not. This one is kind of like a shared responsibility model. Like maybe the Argo CD in the middle pushes certain things like system-wide software. And maybe there's another Argo CD in that other cluster managing the apps, for example. So maybe the Argo CD in the center is pushing things that are wide, like Kivernal or Cert Manager or an ingress controller, right? Something that is used by all the apps, and it's doesn't get that overwhelmed. But it will be like maybe we call them add-ons. I don't know if you call them extensions or system-wide software, but it's software that is used by the apps that are shared, like an ingress controller, the CSI driver, those type of things. But some end users have 30 to 50. I have users that have more. I want to ask like folks like, have you worked with this? How many add-ons do you see in production if you run in production of this system-wide? Like if you add things like Istio and Cert Manager and CSI driver, load balancer controller, What else? External DNS. That adds to how many? 20, 10, 5? Any number?
Around 10, probably.
Ravindra saying 20 to 30.
Yeah,
Yeah, I've
mine's
seen.
about the same.
Steve, did you say how many?
About the same, like 30.
Yeah, so when folks, when I ask end users, some of them say 40, some of them say 40 to 50. And that's one platform team managing those 50 add-ons for 100 clusters, 500 clusters on different versions of those clusters that they don't update for 2 years. And then the add-ons don't work. And then you can update the add-on, so it becomes problematic. But anyway, so have end users that have 160, like Adobe and major companies like that, like 160 add-ons that could potentially go into one cluster, but not all clusters have all the add-ons, right? You have clusters that are doing like machine learning, and you need like the GPU operator, and you don't need it on every cluster, right? And some clusters are for dev, so maybe you don't have all of them, but 100, it can go up to 100, right? In the hundreds. But I was saying that because this Argo CD in the middle can manage maybe say 100 add-ons on each cluster. But if you have a lot of clusters, then it becomes kind of like bogged down even with the add-ons. So this is like things that go at scale. Like if you have a small environment, one Argo CD for everything is fine. And then this is a model that we are trying to do for like those end users are like on the extreme. So what it is the distributed model where the Argo CDs in every cluster, the workload clusters, they are isolated, they're distributed, right? So they would get their add-ons, their apps, the platform, and everything, and the namespaces from the Git repos themselves. But the center Argo CD maybe helps bootstrap the cluster, like install Argo CD on that cluster, and maybe manage it. So if this Argo CD gets damaged, or you want to revert it or want to upgrade it, then you can manage it centrally from the central one. So that's a workshop that I'm building this year, and then it uses different patterns. So let's see a demo of this. How about that? So in this environment, I have an Argo CD, which is this one. It's called the management one. I don't know. Tell me if you see it. The boxes, right? And this is a what's the message on the chat?
It's me, you can ignore it.
So this is the staging cluster. So Argo CD has this thing. I need to put some color in here, but Argo CD has the ability of like putting something in the banner, so you know which Argo CD you're talking to. So I was thinking of putting colors. So this is the management cluster, and then we have another one called the staging cluster. I have three clusters in this cloud provider, which is in the East Coast, I think. Yeah, we have 3 clusters. So the staging cluster is already set up and it has the app running. The prod cluster doesn't have anything installed. It's just blank. So if we go to the staging cluster, so I have staging here, I can do something like get me all the pods, right? Get pods A, and let me make this a little bit smaller. And we have the add-ons like Everno, CSI, and everything, but we also have the app running here. So if we want to access the app, we can do it with a command here, and then just going back to the workshop. And the code for this is in open source, so and showing a lot of Windows. It's in open source, and you run install.sh, and this will create you the 3 clusters. Somebody was asking for that. Going back to the environment, so we have the app, and I think the app is
5G Technology Experience Center Budapest.
I
My
think
name
we
is
have some
Sergey,
sound.
Chief Solution Architect for CI/CD. Today, I'm demonstrating.
Okay. So I have is the app should be running here, and if we want to access it, is I think it's called the UI. So if we bring the UI here, we should see the app running, and then this is like a microservice that is a bunch of app running. So it's the store app, and this is the same app that we use in another workshop called the EKS workshop. But it's an app that you can add things to the cart, go to the catalog, and it's using 5 microservices. Let me see if I can show you how that app looks like. So that's the app in staging. So what happened to this app was, let me show you the Excalibur. So the hub cluster, what it did was it has Argo CD with application sets. It watches a folder for a new cluster added. And then what it does is it starts like cascading and then creating the Argo CD on that cluster, installs the namespaces, installs the add-ons, and then deploys the app. So it goes something like this. Let me see. This is some team member doing that. So this is the staging cluster. It deploys everything in there, installs Argo CD into that cluster, then install external secret operator on that cluster from the remote one. And then external secret operator, what it does is uninstalls the external secrets. And these secrets, what they are is the Git secrets. So to connect to the Git repo through SSH or a GitHub app. And then it connects to something like you can connect to Secret Manager, but you can also connect things like Vault. It supports many what do you call it, provider. Somebody familiar with external secrets in here?
Yep.
Yep.
So that's the bootstrap mechanism. Like externally, like I said, like then this hub cluster can scale because the only thing that is installing is install Argo CD and external secret operator, and then the couple of secrets in that hub cluster. And if this hub cluster is not behaving right, you can just uninstall it, and then suddenly like that cluster doesn't have Argo CD anymore, and they cannot deploy things because no one has kubectl access to these clusters like in production, right? Nobody can like kubectl into this cluster, and the only way that you deploy things is through GitOps. I don't know if a lot of people follow that pattern, like they don't give access to anyone to access the cluster, and they deploy everything to GitOps. And then from that point on, this cluster now has Argo CD, and then it can connect to the Git repos. Let me see if the team added those things. I think then this is how like the orchestration of Argo CD happens with that. So let's show a little bit of that in here. So staging is working, is happy, and the scenario is that you join this company and they told you like we have an app running in staging, and the app is not running in production. It doesn't show well. So we have production here. Can you see the screen okay, or should I zoom in?
That's better, I guess. Yeah.
So the pattern is, and then we can do this get pod -a. This app doesn't have much, have a few add-ons that are installed by the cloud provider, but other than that, nothing installed with Helm. There's no Argo CD here. Has core DNS, CSI, and then some for logs and then metrics to get that. But it's pretty much empty, doesn't have Argo CD. So the trick is we have to deploy Argo CD to this cluster. And the idea is that someone in the team created this cluster and put its information in, it could be Vault or it could be external secret manager. So they put enough information to connect to that cluster. And so in a cloud provider environment, Argo CD doesn't connect with a kubeconfig secret. It connects with what you call it in all cloud providers, workload identity, right? So this Argo CD is allowed to connect to this other Argo CD using this configuration here. So it's going to assume maybe a different role like this one and connect to that other cluster. So one anti-pattern that people do is they, not anti-pattern, but they use the Argo CD CLI to add a cluster without passing the cloud provider flags. And what that does is actually creates a service account and a secret on that other cluster that never expires, and then gets a copy and then puts it in the other Argo CD cluster. So that's kind of like very bad, because then it's a never expiring token that you're moving around. So this is a better approach. So when we have Mark, we can ask him. He does this type of things with his tool, his platform called Unison. So let's look at how we can do this with GitOps. So what we can do is we have here a folder called fleets. We have a folder called members, and then we have one cluster representation here. So this is a YAML file that represents staging. So we have to create the same YAML file for production. So the idea is that let's create that folder. Let me see where that command is in here. So we're going to deploy to production. We're going to deploy this. So we have to create an app like this, saying like, my name is Fleet Spoke Prod. I'm part of Tenant 1. My environment is production, and my details are located in this place. So with this, we should be able to register the cluster to the fleet. So it takes a lot of like configuration to get to this point, but the idea is when you're building an IDP, to make it super simple to add a cluster. It doesn't matter how it was created. It could be created with Terraform, with CDK, with Capi, with anything, but this is how you register this cluster and it connects to it. Let me see, run that command in here. That's not the command. We have to create the file. Did I copy the right thing? We have to copy this file. Oh, this is what it was showing, was the details of production. So I can run that. Let me see. If you want to see the secret. So this is the version of the secret that we have to push for production. So this is sitting in, like I say, like Vault. And nothing here is private. It's just like metadata on how to connect. Take a look at this section. This is what we call the GitOps bridge. It's metadata about this cluster that some Helm charts need some information. So for example, what is it? Carpenter is an autoscaler. We need to, when install the Helm chart from Carpenter, we need something like the node AIN role, and we need something like the SQS name. When we install like the application load balancer, we need things like the cluster name and the VPC ID. So this is where like the cloud, when you run Argo CD in a cloud provider and you install Helm charts, you have to pass this information, and some people just hard code it. And a story that I can share is a big company. You see this account ID here? It's a number. They did a typo, and the person putting the file in Git manually means a number, and they had an incident. They had downtime, and this is like a company that's selling like ticket events that a lot of people sign up and then buy the ticket. So they took some time to figure out that somebody put this metadata in Git and they did a typo. They didn't have automation, but this is what things like this would avoid. If you have this metadata like provision as part of when you create the cluster and you add things to the cluster, the automation will put this information here, and this Argo CD will use this information. Anyway, let's add the cluster and see it come alive. So like I said, it's empty. Not much in it, and then it doesn't have Argo CD in it. So And what was the command that I wanted to run? This one, right? So we're going to create a folder with that information. So if we run it here, now we should have two folders, one for staging that was showing and one for production that is sharing. And these are the GitHub repos or Git repos. And now Argo CD will start like discovering this file using something like an application set, which I can show here. So if we go to the fleet, and application set is like the most powerful thing of Argo CD when you get into multi-cluster management and also multi-apps in different environments. So if you go to Bootstrap, what this is doing is watching that folder to deploy. Let's see if it's this one. So it's watching that folder. So this is Argo CD. This is an Argo CD application set. There's something called generators. There's a Git generator that is watching that folder. And when it watches that folder, it's going to parse the information from it, like this one, these values, and then inject them. Where's the application set? I think I lost it. It's going to deploy a Helm chart and then pass that information from that file into this Helm chart that creates a external secret with this annotation. So at the end, the Argo CD hub should have a secret. So if we do get secrets -n Argo CD, for every cluster that Argo CD connects to, it will have a secret representing that that cluster. And it's not here because I think on this version we have the Argo CD, like it's as the default value of every 3 minutes. So it refreshes. Here it is. So things start moving now. So let's I think I talked enough for 3 minutes that the thing show up. Let me see if it's there. So see here, there's a new secret. This is what Argo CD uses to connect to that, to the cluster. In this case, the production cluster. So now it's pushing stuff to it. Not stuff, but the bootstrapping. So if we do get pods, what is the command? Okay, get pods or namespaces actually, right? We can see that there's a new namespace called Argo CD. And then if we look at what's inside that Argo CD, we can get pod -n Argo CD. And then as you can see here, it looks like it's installing Argo CD things and external secret. So this is a way of like easily bootstrapping clusters with Argo CD. So the only thing that this Argo CD is deploying is Argo CD. Let me see if there's more stuff here. Yeah. So for every cluster that now your fleet has, like if you have another cluster coming next week, it's basically the same process of like adding a file with 1 or 2 variables, and then an Argo CD gets sent to that Argo CD. So once it's up and it has the secrets to connect to Git, then it will kick off installing the add-ons, right? So that's the next thing that we need to install is add-ons on this cluster. So questions so far? To this point, a lot of end users, these are the type of questions that they ask, like, how do I add a new cluster to the fleet? So they always ask like, well, then who installs Argo CD? And how do I get Argo CD installed? And how do I get the secrets for the Git to get to Argo CD? And it becomes very complex for these different environments, and even if they're new to Argo CD or GitOps. So we try to create this framework called the GitOps bridge, where it has these patterns of application sets already configured out of the box to make it super simple. Questions, comments?
Yes, Carlos.
Go ahead.
Okay, I think I don't know if I'm before Jack, but I'll just go for it.
Oh, after you, please. After you, please.
Thank you very much. So basically, I have a question since it is cascading to other clusters, and probably it's like AWS context. Maybe it does not apply for all Kubernetes cluster. But if you, for example, install, I don't know, maybe AWS load balancer controller or external DNS, you might need, for example, IRSA, which needs some AWS policy in the spoke cluster.
Yep.
Is that something that Argo CD can do, or you should take into consideration that you need to create a role in your spoke cluster, for example? Not only in the role in AWS, but probably also access identity or pod identity or something like that.
Yeah. So you're talking about that and we're going to see this. That's the next thing. So Argo CD, actually external secret needs access to it. But yeah, you have to create a let's say any cloud provider, right? You need to create a workload identity in the cloud provider, and then associate that workload identity with a controller in your cluster, and that could be things like a CNI, CSI, ingress controller, the application load balancer controller. So that role needs to be created. In this workshop, we happen to use Terraform to create that role. In AWS, it's called AIM role. I'm trying to be generic. Sorry, an AIM role. So someone needs to create that. You can use Terraform. You can use CDK, but also you can use Kubernetes controllers to create those roles. So one is ACK, can create that. So you can put like YAML to create the role for the application load balancer controller, deploy with Argo CD, or things like Crossplane. So a lot of people use Crossplane or ACK or Capi. Capi has extensions to create these roles. When you to create these roles, then you have to create the Helm chart. And then that's what I'm going to show. Like, then once you have an ARN, how do you pass it to the Helm chart to get deployed? So yeah, Argo CD can help, but only if you are using something like ACK, Crappy, or Crossplane that are like Kubernetes controllers that can create these roles. So yeah, good question. So let me show you an example of that. So that cluster was created. So if we go to the hub cluster, actually in here, in this namespace called Argo CD, there's a secret. Get secrets -n Argo CD. There's a secret called, it's an Argo CD secret. It's called this one, Fleet Spoke Prot secret. That was deployed by the central Argo CD. So if I do the same command, this -o YAML, in this framework, what we do, and a lot of people do, like not this framework, but a lot of you look for a lot of presentations on Argo CD from KubeCon. A lot of people do this pattern of using the Argo CD cluster generator. So in this case, the cluster, Argo CD cluster secret you can put information in the labels. So see the labels here, or you can put information in the namespaces. Let me put this a little bit here in the namespaces. So as you can see here, one of the information that we put in these namespaces, look at this section here. What does it say? Well, in this section, we're using pod identity. So we already configured the pod identity, but we need to know the service account. That's important. And the namespace. And that gets passed to the Helm chart. But if you're using IRSA, the ARN role will be located here. Using EKS pod identity, you just associate it to the cluster. So the next thing that happens is the add-ons. I don't think the add-ons are deployed. Let me see. 1 second. Yeah, so the add-ons are not deployed yet. The add-ons get deployed in the add-ons folder. I have a folder called for clusters. I have a hub. I have a spoke. As you can see here, the spoke has a Helm chart. It's called the GitOps bridge, but I think I'm going to change it to cluster add-ons. And this is where I enable for this cluster, like which add-ons do I want to deploy, self-deploy in this cluster. So in this case, the the staging cluster has the application load balancer controller and the CSI classes and metric server and Carpenter and Kyverno and all these things. And you can put like, we support like 70 add-ons, and you can add your own add-ons in this Helm chart that gets deployed. So to deploy that, if we run something like, we go to add-ons, we basically need to add a folder and that YAML file that I show. Like, we have to duplicate this folder, fleet spoke staging for production, and we deploy. But you can also add it here on the environments. You can add it to production and get deployed. Everything in production gets the same clusters, or by default you can deploy the same clusters everywhere. But just for training purposes, we did it like this to deploy production. So let me get the command from here, and then the command is like a git push again. So we're going to add that folder with a git push. So if we run this here, we have a that folder. I added that folder, and then the configuration for Argo CD is like, I want a banner that points to a different environment, for example, and then this one in here. Actually, I should have put their production. I didn't put it. Oh, production is down here. Like everything in production, I think I put it here, like production environment. But going back now, I'm going to get these add-ons deployed into production. So if we, I have not showed you the Argo CD in prod. Now that it's there, I can show you the Argo CD actually running there. Didn't show you that. So let me log in. Admin production. So this is production. So now it has Argo CD, and it has some namespaces, or has some application sets, but they're empty because it's waiting for the app to be deployed. So in this case, after 3 minutes, or we can refresh the hub cluster to deploy the add-ons if we want to. So we can refresh here. Let me see. We can refresh fleet members. Fleet members, I think I call it. Here's the prod. Oh, add-ons. So it's already deploying the add-ons. Yes. Let's go to the add-ons. But the add-ons is in the other cluster. So let's see if they come up. Refresh. There you go. So this is how you deploy your 30, 50 add-ons is with application sets. So in the application set, this is the bit that I was telling you about, that when you deploy an application set, then you need to pass things like the IRSA or the service account. So as you can see here, I'm not using IRSA, but that's why this is empty. But I need to the service account and the namespace where I'm deploying this Helm chart. So basically the framework, what it does, it creates this application sets over and over and over for every type of add-on, like Kyverno. I think we have Kyverno here. Kyverno, we're deploying Kyverno, so this deploys the Helm chart for Kyverno. 306 Kyverno, and Kyverno doesn't need anything from the cloud provider, so it's just a generic one. And then you have your overrides with Helm values that you can override from like very generic to very specific. Like on this cluster, for example, I need a specific configuration, or in an environment, I need a specific configuration. So environments, cluster, or maybe Kyverno 3.2, I need specific values.yaml. So the way Helm works is if you pass different values.yaml file, I believe the last one wins. So you can pass in this order, and you can specify them all of them in the environments here. So if you go to environments, maybe in prod is different than staging, and you have different configuration. and you deploy the add-on. So the add-on should be running here. So let's take a look. Get pod-A. And all the add-ons are deployed here. So now we have Kubernetes, for example. We have things like load balancer controller. We have things like external carpenter. What else? We deployed. I think we deployed metric server. So all those add-ons are located here, and they get deployed automatically, but just by doing on and off on the thing that I show on and off in here. How are we doing with time? Any questions?
I have one question. Last question, Carlos, please.
Yeah, go ahead.
Okay, thank you. For the life cycle now, it will be managed by the Argo CD instance in the spoke accounts respectively for each add-on?
Yeah, from this point on, the only thing that the central hub did in here was to deploy the Argo CD, install the Argo CD, and deploy the external secret operator. From that point on, it may deploy things like and the initial like application sets, like the cluster add-ons. But yeah, anything is minor touch from the hub cluster, so we can delete the hub cluster. This cluster will continue working, right? With Argo CD. That's the kind of like the avoiding the single point of failure, or like if this Argo CD needs to be maintained. But it's kind of a helper to Bootstrap. You don't have to use this. Other end users, what they do is use Argo workflows. So when they, for example, somebody adds this folder, like I showed, right? In the fleet folder, they add a new member, they have a GitHub action or an Argo workflow that goes ahead and then like do a kubectl apply, install Argo CD, external secrets, and bootstraps the cluster. And then from that point on, it's known. I decided to just to show a pattern that is useful. Use Argo CD to install Argo CD. That makes sense? That answer your question? But yeah,
Yes,
the now production and staging have their own Argo CD. They deploy their own add-ons, and also the applications. I think somebody has a question. Daniel?
Yeah, so could that hub cluster be used to like maintain the Argo CD versions in the other clusters as well? Like, say we need to update Argo CD in all the clusters?
Well, the way that this Argo CD is configured, where's this Argo CD? Let me look 1 second. It was here a minute ago. Cluster add-ons. So if we need to upgrade the version of this Argo CD sitting in prod, as you can see, we didn't configure it. We can have Argo CD deploy Argo CD, and then this Argo CD can manage itself. Like that's one option. For some reason, I didn't do it. I didn't show it here, but that's one pattern, right? Maybe that we can show both. But in this case, I will need to upgrade this Argo CD from the hub cluster. So it's a matter of stating like what are the values.yaml that I want to use and the versions that I have to use in Git. So for example, this Argo CD is managed by Argo CD. So if you go to the Argo CD app for here, you can manage it, right? It's deploying Argo CD from a Helm chart. So if I modify any of these values in Git, it will upgrade the Argo CD. So you can have it both ways. That answer your question?
Yes, thank you.
And most people, they manage Argo CD from Argo CD. So yeah, that's a good question. It depends what the team wants to do, right? If they want to let the spoke cluster manage its own Argo CD version, that's kind of like risky. Like if something happens and there's something wrong, you have to log in here and like do a force sync or replace, or if they have access, or they can just go into the management cluster and force sync in there. So it depends on that aspect, how they want to do it, but it's flexible. It's GitOps and it's YAML files. So to close, let's see, we can deploy the app and then we'll close. To deploy the app, basically we need to add in here. So this is the application, right? It's a multiple microservices. There's a UI. We have orders, checkout. Most of them use a database. It has DynamoDB, MySQL, Redis. These are the namespaces that get deployed. And the way that this is configured is with Argo projects and teams. It's like a multi-tenant. Like imagine if you have like the front-end team and the back-end team, and some of them own some namespaces and the others don't. So you can like deploy the namespaces with network policies, with limit ranges, resource quotas, all those things. So to deploy that, we can add an application set. Again, everything is an application set. To deploy that, and basically I onboarded the team. So this is like onboarding multi-tenants. So in the platform folder, I have a folder called teams. And for every team or tenant or group that I want in every cluster, or Argo, in this case, staging and prod, I will have like their Argo projects that states like what they can do on that Argo project, Argo CD. I can have the namespaces that are allowed to be deployed by the front-end team, and the same team for the back-end team in prod. So you can add multiple folders here for teams, and that will deploy the namespaces. So for namespaces, there's a namespaces application set that gets deployed. So in that case, we have our namespaces. So let's check the namespaces here. So now in production, we should have namespaces for the app. Well, it takes 3 seconds. I should put this down into like small amount of seconds so it can refresh. Let me see. Let me refresh. Do I refresh all the apps, or see what can go wrong with refreshing everything? I'm just doing a refresh instead of finding the correct app. I'm refreshing everything. So we just have namespaces, namespaces for each team, and the namespaces are created. So for example, you can see here the limit ranges, the namespaces, the resource quota. We can add the network policy. So this is the platform team taking charge of the namespaces. The app team don't have to mess with the namespaces because they're going to have quotas and limits. So let's run that command again to see if we have namespaces. So you onboarded the namespaces now. And now that we have namespaces, this is kind of a separation of concern, like namespaces versus app. So that's the namespaces. And then for production, we have to deploy the app. So we're going to deploy a folder. We're going to use customize to deploy a folder that is empty right now. It's called prod, but we're going to add a prod customization.yaml file. So if we run that, we should see in the apps repo the backend and the front-end team. And then, like, for example, the backend team now has a folder called prod. So I just added that with this command. For cards, for catalog, we have prod. So we have a customized.yaml for each one. And I think the UI is different in prod. We add an HPA with more replicas in production than staging. Staging uses the base for HPA. We don't want that many replicas in staging, just to show a difference on that. But again, if we go to the applications, let me refresh in here because I don't have the Git webhook. I can refresh, and then the app, now the app team only needs to deal with the app's Git repo. And so the backend team can, make changes here for the configuration, deployment, config map. They cannot change the limit ranges or the namespace. And then the front end team can can configure their deployments, their service, like things that were allowed by Argo projects. Argo project is not letting them do everything they want, only the things that we want them to be allowed to configure. So they can put everything here. So they don't have to be concerned. The app team doesn't have to be concerned on the EKS cluster, Kubernetes clusters, or how they get provision or anything. They just push things in here, and they can have a CI/CD pipeline, right? That changes the for example the image of the application when they make changes, and that could be a CI/CD pipeline like workflows or GitHub Actions. Do we have an app? Let me see if I have an app. So if we do, this is refresh. Now we should have apps in here, or more pods. And as we add more pods, they go pending. And then Carpenter is a autoscaler that will provision a specific instance for the app, for the pods. So we have the catalog, cards. We have the UI is deployed, RabbitMQ, MySQL, everything's deployed, and we should have a namespace, a URL for this app in production. So let me open it and see if our homework DNS is still updating, but that should be the app running. Like it should look like this in production. Any questions? I know that this is a little bit advanced multi-cluster Argo CD configuration, but this is the type of stuff that goes in production. Go ahead, Jack.
Yeah. Okay. So lots of questions and no